Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever, and we are going to dive right into exponential equations using logarithms as we listen to a cut from the new hot CD just out called Dave's Faves. My good friend Dave over there, another one of his faves. Coincidentally, not coincidentally, because who doesn't have this as a fave? One of his faves is exponential equations using logarithms. So, let's get to it, shall we? We shall kickstart My Heart Again by Motley Crue at the end of the vid. Alright, here we go. See you later, Dave. Now, consider the equation 2 to the x equals 30, part A. Let's solve for x, giving an exact answer by using base 2. And also using base 10. So if you recall, before we had some exponential equations that were quite easy to solve. For example, if I had, 2 to the x equals 8, I could write that as 2 to the x equals 2 cubed, and even before that, clearly x equals 3. But now here, we don't have that, okay? We don't know 2 to the what is equal to 30. So we can use logarithms to solve this equation. And they first ask us to use base 2. Well, this is quite convenient because if I take log base 2 of 2, well, I should back up. When solving equations using logarithms, what we do is we take the logarithm of both sides, and eventually we'll be able to isolate the variable and get x equals something. So I'm going to take the logarithm of both sides, like so. But right now it's base 10, but I was asked to do it solving base 2. So I'm going to make these base 2, and hopefully you see why I was asked to do that, because log base 2 of 2 to the x is simply equal to x, and if you recall, log base a of a to the x is equal to x, as long as the base matches the argument. So we have an exact solution of log base 2 of 30. And we say that's exact because if we were actually to crank it in the calculator, we would get a decimal approximation for this. But this, just like pi, is an exact answer. An approximation for pi would be 3.14. But we know that's not exact. Pi is exact. So same idea here. And now we're going to do it with base 10. So I would have log of 2 to the x equals log of 30. And by laws of logarithms, the x can move out in front of the logarithm as a coefficient. Now remember, these logs are numbers. They're actual numbers. So what I have here is multiplication happening with the variable. So I can just divide both sides by log 2 to cancel out the log 2 on the left side. And please, please, please understand, this is no different than, 6 over 6, 6x over 6 is equal to x, because 6 divided by 6 is equal to 1. We are not canceling out the L and the O and the G and the 2. All of this together is a particular number. Just to hammer that home, let's take log of 2, log, I should put parentheses, 2, and it's a number. That's an approximation there. So when it's base 10, if there's no base, there's base 10. So it's that exact same number, that number over the exact same number, that's equal to 1. So the exact solution is x equals log 30 over log 2. Okay? And they say comment on your answers. Well, what they're getting at is this is the same x. So what we can conclude is log base 2 of 30 is equal to log of 30 over log of 2. And this is a prelude to a new law that we're going to use called, or rule, it's called the change of base rule. That comes a little bit later. All right, find x exactly. Well, for this one, remember that log base A of B is equal to C. If and only if, this is another way to express if and only if you remember, I've been using that. If and only if A to the C is equal to B. So I'm going to go from exponential to logarithmic, and I'm going to be able to say that the natural log, my base is E, but I don't have to write it since I wrote natural log. It's just understood that there's an E there of 30 is equal to X. Done. Done, 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 done. Okay, so here we're going to have to do a little bit more work. 3E, that's actually an X over 2, is equal to 21. I'm going to clean it up a bit and divide both sides by 3. Again, this is just a number. E to the X over 2 is a number. Once we find out what X is, we'll have an exact number. So, or we would, E to the X over 2 is equal to 7. Well, now if I take the natural log of both sides, natural log of 7, natural log base E of E to the X over 2, that's equal to X over 2, equals to the natural log of 7, multiply both sides by 2, and X equals 2 multiplied by the natural log of 7. So easy peasy, easy stuff. If you know your laws of logarithms, makes solving exponentials very, very simple. Okay. Rearrange the equation to give t in terms of p. So that's another way of saying solve for t. Well, anytime you have a variable as an exponent, you're going to use logs to isolate that exponent. So we can use natural logs, we can use log base 812. It doesn't matter. Usually if e is not involved, I'm just going to go ahead and use regular old logs base 10 and divide both sides by 200. So let me write this. P equals 200 times 2 to the 0.04t. I think that'll be easier in the long run. Divide both sides by 200 first. So now I have p over 200 is equal to 2 to the 0.04t. Now I'm going to take the log of both sides. Log of p over 200 equals log of 2, 0.04t. Okay. And then I would have log p over 200 is equal to 0.04 t times log 2. Okay. Now I'm just going to rewrite this one time just so you can see it. Log p over 200 equals, I can, multiplication is commutative, so I could rewrite this as 0.04 log 2 times t. Maybe I should do this to emphasize that where I'm not taking the logarithm of t, that's this number multiplied by t. And so, since it's something times t, I can divide by that. So 0.04 log of 2 divide by 0.04 log of 2. And I finally get it. That log of p over 200 is equal to 0.04 log of 2 equal to t. So we've done part A quite nicely. Yeah, I could rewrite this as log p minus log 200 if I need to, but this is a perfectly acceptable equation. And now they want to find the value of t when p equals 6. So for part B, I'm just going to replace p with 6 and crank it in my calculator. So let's see. Let me move this up a little bit. Oh, that's all right. I'll remember it. Log of 6 over 200. So let's see. Control log 6 over 200. Oops, what happened there? I went into the base. Got to go in here. Log, bam, 6 over 200. And we're going to divide that by, I forget already, 0.04 log 2. I better put parentheses just to be safe. 0.04 log of 2. And you want to put parentheses, otherwise it might just divide by the 0.04 and then multiply by the log of 2. Okay, but that's what I'm after. So there I have my answer. Let's get a picture of that. We get approximately negative 126.4 to 3/6 figs. That would be negative 126. Example, we'll be using our calculator again. Find algebraically the exact points of intersection of these two functions. Check your solution using technology. Well, we already know that the intersection point comes when the two functions are equal. So I'm going to set them equal to one another. Okay, and then I'm going to gather my variables on one side. So e to the x minus 3. If I add, so this is going to be plus 3e to the negative x minus 1 equals 0. Let's combine what we can. E to the x, I'm going to put plus 3e to the negative x right here. Minus 3 minus 1 minus 4 equals 0. So it's looking suspiciously like a trinomial, and whenever I think of, it's actually not looking like a trinomial, it is a trinomial. And whenever I think trinomial, I think of quadratics. And is there any way I can make this a quadratic? Well, take a look at this. And I say that because if I make it a quadratic, then I could possibly factor it and use the zero product principle. Well, what's bothering me here is I have e to the x in the denominator. But what happens if I multiply everything through by e to the x? Well, e to the x times e to the x is e to the x squared plus e to the x plus 3 over e to the x. The e to the x's cancel, and I have 3, and then minus 4 e to the x equals 0. Let's rewrite that as e to the x squared minus 4e to the x plus 3 equals 0. And if you have trouble factoring these with the e to the x, then just off to the side somewhere, do something like, okay, let k equal e to the x, and then we'll substitute it back in. Well, then I just have k squared minus 4k plus 3 equals 0. So I can factor that. K minus 3 times k minus 1 equals 0. So then k would equal 3, or k would equal 1. Substituting back in, e to the x would be equal to 3, or e to the x would be equal to 1. Then I would take the natural log of both sides. Natural log of e to the x equals natural log of 3. Natural log of e to the x equals natural log of 1. Well, let's have a look-see. So natural log base e of e to the x means x equals the natural log of 3, or natural log of e to the x is equal to x. So x would equal natural log of 1. So with x, the natural log of 1, we know what that is equal to. That would have to be equal to 0, because e to the 0 equals 1, if you remember our relationship. So we have x equals 0, and x equals the natural log of 3. Okay, so then I have an x equal to 0 here, and then an x equal natural log of 3. And then I find my y-coordinates by substituting into either of the original equations. I'm going to choose this one. Well, e to the 0 power is 1, and 1 minus 3 is negative 2. And then e to the natural log of 3 is equal to 3. Okay, and so now let's check that out with technology, and we will graph it and have a look. So go to my graph, and let's have those functions in front of us. So e to the x minus 3, boom. And then one more function, 1 minus 3, and then we have to do e to the negative x, boom. And so we do have two intersection points there. Let's zoom in a little bit just so we can get a better look. Window zoom, zoom box, and I'll just go right around there. Bang, okay. And then I'll just find my intersections, menu, analyze graph, intersection, so here, 0, -2, menu, analyze graph, intersection, here, and I get 1.10. Now remember, we said 0 works as, actually we had natural log of, well, the teacher's an idiot. E to the natural log of 3 is 3, but then I have to subtract 3, so that would be 0. So that's why that works out. Good thing I checked with technology, so sorry about that. But what I want to do is show you that the natural log of 3 is indeed 1.1. So let me escape that, go here, and I'll just do natural log of 3, and it is about equal to 1.1. So we have a good solution right there. If you were doing this on the exam, we've checked our solution anyway. If we were doing this on an exam and this is how we solved it, we would need to just do a quick sketch of that. All right, aside from the minor error towards the end, hope you enjoyed that. I enjoyed it very much, and we shall continue with Dave's Phase, Kickstart My Heart by Motley Crue. With that, I am out.